Was the video camera on? See, you all do this kind of thing so fast. In 10 seconds, you can finish it. Okay, anyway, so yesterday we have touched on 3 diagrams already, right? Okay, so we will now move on. Okay, by the way, I want to add one more question to the board here. Just one question, 7.
Oh no, it's in the front.
It's okay, just continue and continue.
Sorry, Josh.
Okay, we're going to look at addition of probability, right? Something that's newer. Okay. So first of all, we're going to understand what is the meaning of mutually exclusive events, and then after that, what the addition law actually implies. Okay. So if 2 events, right? So for instance, we name them A and B. There will never be an even number that is also odd, and there will never be an odd number that is also even. So we say that A and B are mutually exclusive events. Okay, if you want to say in a Venn diagram kind of manner, you can consider it as a disjoint set kind of situation. Okay. So they are disjoint. Okay. On the other hand, they will not be mutually exclusive if so a counter example. Okay. Also a deck of cards. If I'm looking at maybe A to be a even number card, and then B to be prime number card. Okay. Then these 2 events are not considered mutually exclusive, right? Because there is an even number that is also prime, and that is number 2. Okay. Understanding about mutually exclusive. Okay, so in this case, if that is the case, right? So if you were to look at probability, okay, then the probability of A union B. So meaning to say, okay, maybe I'll state out the law first. If 2 events are mutually exclusive, then the probability of A union B is equals to the probability of A plus the probability of B. So in this given example over here, okay, if you're looking at getting a probability of the event choosing an odd number or even number. So if you choose from a deck of cards, okay, choosing either an odd number or an even number, okay, the probability itself, you will find that it is the probability of getting the odd number card plus the probability of the even number card. Okay. So what would the probability of the odd number card be? Half? You sure? There are 52 cards in total, right? How many odd number cards are there?
The JQK not counted.
JQK not counted. Is A considered a 1?
Yeah.
Okay, then after that.
Learning a poker now. Let's go.
Okay, so then how many odd numbers would there be in deck of cards? 52 cards, right?
Times 4. 36.
5 times 4, so that is...
So it's 9 times. Wait,
5, right? 5 odd number cards, right? In each set. Then after that, 5 times 4, that's 20, right? So 20 odd number cards out of 52 cards, right? Even number also the same.
And Queen Jack.
Okay, Jack, Queen, King are considered picture cards. Okay, so that will actually be 40 over 52. So simplify and divide by 4, right? Then over 113. Okay, so that would be the probability. Okay. Then after that, in the other case, if I were to be looking at non-mutually exclusive events, okay, not mutually exclusive. So if I were to be looking at probability of getting an even number or prime number. Okay. So how many even number cards are there actually? Just now we said that the probability of getting even number is actually 20 over 52, right?
Yeah.
Then what about the probability of prime number?
4.
That would be considering 2, 3, 5, 7.
9.
2, 3, 5, 7 only, right? Okay, so that is 4 times 4, so 16 out of 52. Alright? Whereas if you were to choose even number of prime numbers, okay, the sample size will actually be 2, 4, 6, 8, 10. Prime number will actually be 2, 3, 5, 7. That's all. Alright? That's the sample, not the exact sample space, okay, but these are numbers that we will consider from the deck of cards, correct? So there will actually be 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4, that's 32. So the probability in this case is 32 out of 52 to satisfy this event. Are you all following me so far? Okay. But in this case, if I were to take probability of even number plus probability of prime number, that will give me 36 over 52. So the probabilities don't match up. Okay. So what I'm saying is that, okay, if mutually exclusive events, you will find that, okay, if the probability of A union B is equals to probability of A plus probability of B. And I like to emphasize also that usually in our wording, okay, when you see the word or, okay, or will represent union. Okay. So whenever you want to do addition of probability, you need to really ask yourself, are the events actually mutually exclusive or not? If they are not, then you will not be able to actually add the probabilities up. Most of the time they would actually give it to you as mutually exclusive events. Okay. You understand? So if not mutually exclusive, then you really need to consider and do your counting on your own. You understand what I'm saying? Do I need to repeat? Yes? No? Yes? Sorry?
Why is it 32?
Why is 32 over 2? Because the number of even numbers, the choices of even number cards are 2, 4, 6, and 10, right? Prime number cards will be 2, 3, 5, 7. So the total will actually be 1, 2, 3, 4, 5, 6, 7, 8. 8 cards. But there are 4 different types, right? In the set of cards, in the deck of cards. So 8 times 4 is 32, right? So 32 out of total of 52 cards. Okay? So if not mutually exclusive, we will have to consider the cases and then count our probability on our own. If mutually exclusive, okay, we can use the addition law of probability. Any questions on this? Okay. Can I erase? I erase this part up. Okay, let's look at practice now 6. Okay, so practice now 6, we are looking at deck of cards, will be 2 of them. Okay, then after that in part 1, we want to find the probability of having a picture card or an ace. Okay, so how many picture cards are there in a deck of cards? 12, right? Okay, so there are 12 picture cards. And then after that, how many aces are there? 4. Okay, is this a mutually exclusive event?
Yes.
No? Right? Yeah.
Yes.
Is it yes or no? Mutually exclusive is if they cannot occur at the same time. Okay? So they cannot occur at the same time. They are not related to each other. Alright? So therefore in this case, to find the probability that we want, okay, I just do the working up. Right? We will have 12 out of 52 plus 4 out of 52. Okay? Then you will get 4 over 13 simplified. Okay? Then part 2, the probability of choosing a card that is either an ace or a card that has number divisible by 3. Are they mutually exclusive events?
Yes.
They are, right? Okay. Ace is considered a 1, 1 is not divisible by 3, so they are mutually exclusive. So therefore, we have 4 ace. How many cards have numbers that can be divided by 3?
3, 6, 9.
Only 3, 6, 9, so 3 times 4, so that would be 12 cards, right? Okay, so the probability will be considering the ace plus 12 over 52, number divisible by 3. So we will get 4 over 13 as well. Right? Eh, sorry. Yeah. Yeah, right. for part 3, okay, choosing a card that is either a king or queen. So taking a king, the king can't be a queen, the queen can't be a king, so they are actually mutually exclusive. There will be 4 kings and 4 queens. So we can add up the probability. And then the answer will be 2 over 30. Okay, then after that for last one, right, this one, okay, we may want to look into the reverse, okay, probability of neither jack nor ace, okay. You wouldn't want to start counting how many are not jack and how many are not ace, okay. So we can consider it as 1 minus probability of jack or ace, okay. So 1 minus the probability of getting a jack or ace. Okay, so the probability of getting a jack will actually be 4 over 52. And then after that, the probability of getting an ace will be 4 over 52 as well. So calculate that and you will get 11 over 13. Yes, it's yours.
I said you don't write the probability of
I think I already addressed that question, right? For that. Yeah, what is an alternative? Okay. I am just not repeating it because I don't want to rewrite the same thing that I've just written. I don't want to waste my time